Okay, let's try this example. Here they'd like us to determine the main bonding or intermolecular interaction experienced by a sample of xenon tetrafluoride. Remember, be systematic. Start at question 1. Question 1 is, do you have a metal with a nonmetal? No, xenon is a noble gas. It's a nonmetal. Fluorine is a nonmetal. We don't have a metal. This is probably not an ionic compound. Question 2, is this one of our fantastic 5 network covalent examples? No, this is not one of the key examples that we've memorized. This is probably not a network covalent material. Example number 3, do you have just a metal? No, we don't have just a metal. We don't even have a metal. This is not a metallic structure. Therefore, we probably have a molecular compound. XeF4 is going to be composed of tiny molecules that are held together by weak intermolecular interactions. Before deciding on what those interactions are, you need to draw your Lewis picture. So let's go ahead and do that together. XeF4, in order to get this Lewis structure, we need to add up the valence electrons. So let's add up the valence electrons for both xenon and for fluorines. Xenon has 8 valence electrons. We have 4 fluorines, and each fluorine has 7 valence electrons. 7 times 4 is 28, plus 8 more. We have a total here of 36 electrons we get to put in our Lewis picture. Step 2 of drawing any Lewis picture is put the least electronegative atom in the middle, or put the different one. XeF4, let's put xenon in the middle. And then we're going to connect single bonds to fluorine. So here's our xenon with 1 fluorine, 2 fluorines, 3 fluorines, 4 fluorines. I just used up 2, 4, 6, 8 electrons out of my tally. And if I subtract that, I get a total of 28 more electrons I get to put in my picture. Step 3 of drawing a Lewis picture says, fill in the octets of your outer atoms. Let's do that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to take away 24. I got 4 left over. Leftover electrons go on your center atom as pairs. It's okay to do this with xenon. Xenon can expand its octet. It can have more than 8 electrons because it's in the 3rd row of the periodic table or below. Those elements have d orbitals. We can put those extra electrons into those d orbitals. So I've got 4 left over, 2, 4. There's our Lewis picture for XeF4. So now we can get back to our intermolecular questions. Question 4, do we have hydrogen bonded to F, O, or N? No, we don't have a hydrogen atom here. This is not a hydrogen bonding interaction. Your final question is, look at XeF4. Is that a polar molecule or a non-polar molecule? Well, just looking at the Lewis structure, it's difficult to determine that. You really need to sketch out the molecular geometry here. If we look at our XeF4 molecule, there are 6 electron domains, 4 bonds, and 2 lone pairs. So I'm going to sketch out the geometry for 6 domains. That's an octahedral geometry. I'm going to draw 1 up, 1 down, 4 in a ring around the middle. So these are all my domains. Now, if we're going to go ahead, I started to draw the fluorine in there automatically. You'll see this in a second. If you're going to look at your angles, the angle from the top to the ring is 90 degrees, and a ring 360 degrees that's split 4 ways, well, those are also 90 degrees. So on this geometry, it does not matter where you put your first lone pair. I'm going to go ahead and put it in the top position. Here's one of my lone pairs. Now, it does matter where I put my second lone pair though. Lone pairs need a lot of room. So if they're going to get a lot of room, I'm going to put my second lone pair directly opposite it. Those are my 2 lone pairs, and this is what I had started to draw in. These are my 4 fluorine atoms. Now, looking at that structure right there, this is a symmetric structure. All the dipole moments are going to cancel out. The pull from fluorine this way will cancel with the pull from fluorine this way. These two fluorine atoms, their dipole moments will go ahead and cancel out there. The lone pair on the top cancels out the lone pair on the bottom. So overall, XeF4 is a non-polar molecule. Therefore, the only intermolecular interactions for this molecule are London dispersion forces. I hope that helps. Take care.